All right. Hello, everyone. My name is Franklin. Welcome to Comp 2160 Programming Practices. I hope that you are all doing okay today. I am feeling good today because I am here with all of you. Thank you all for coming to class today. I'm also happy because I rode my bike here today, and it wasn't super windy when I was biking in, and I was biking into a headwind, but the wind has gotten much stronger, and it's going to push me home. So I'm feeling really happy about that. Welcome to Programming Practices, Comp 2160. I'm going to start by telling you what you should be able to do by the end of today's lecture. This is typically how I start my lectures, telling you about the learning outcomes of this course to give you an idea of what you should expect to be able to do, and then ultimately with the idea of that you should expect to know how you're going to be assessed throughout the course. So what I'm going to ask you to do on assignments, what I'm going to ask you to do on term test, what I'm going to ask you to do on the final exam, to give you an idea of what you're expected to do throughout the course. So today, what I'm expecting you to be able to do is find some course information on the course website. So I'm going to take you on a little tour of our Learn course webpage just to make sure that we're all on the same page. I know that all of you have taken at least 2 courses before in computer science to get here, so you should have a sense of how to use Learn. I just want to show you where you can find stuff on the way that I, just throw things into the heap that is our computer science course. I want to make sure that you can find everything that you need throughout the term. The big thing that I want us to be able to do today is build and execute programs from a command line environment. This is something that is a bigger learning outcome that we're going to revisit throughout the term. So this isn't the only time that we're going to have this learning outcome today. Today, what we're going to do toward this learning outcome is I want to show you how to connect to a remote Unix or Linux server using a program called SSH. I want you to be able to choose a text editor. Just by a quick show of hands, how many people are using VS Code? Almost everybody. Almost everybody. You've all chosen a text editor, but I'm going to try and convince you to choose a different text editor. And I want you to be able to use a text editor on a remote machine to be able to create text files. So you've all taken 1020. You've all taken 1020. You've been using VS Code to write Java programs. VS Code is a text editor. When you are writing Java code, it is plain text. We are going to use a different text editor to create text files on another computer today. That's the goal for us to be able to do for the end of today. But before we get into any of that, tell you about myself. I'm Franklin. Hello, you can address me as Franklin. My preferred pronouns are he, him, and his. My office is in E2418, so that's just upstairs. And then at the end of the hallway, that's the really, really long hallway that has all the CS profs in it. I'm the one that's closest to the stairwell. There's a sticker of a teapot on my door, and then there's a teapot inside my office. And I don't really drink tea, I drink coffee, but when you take Comp 3010, it's a joke that you will all laugh at. And you're all going to think back to this moment, and you're going to say, haha, that was very funny. Yes, you are all going to do that. You're all 100% going to do that. I am going to be having office hours this term from 2 to 3 p.m. on Tuesdays and Thursdays. Office hours are a time for you to come and ask me questions about course material. They're a time for you to come and talk to me about questions that you might have about the way you've been assessed on things. They're a time for you to come and talk to me. I'm a resource that you can take advantage of in this course. I am here to help you with the course material in this course. If you need some extra assistance, please feel free to drop by. You can also get in touch with me by emailing me. This is my mainly preferred method of communication is by email. That's my email address. If you are going to email me, please use your myumanitoba.ca email address. I basically want to make sure that emails I'm getting, especially for things that are like, I'm concerned about my grade or I have questions about my grade, are actually from the person that's asking the question. I want to make sure that it's actually that person asking the question. If you use your Gmail, because I know then in like Gmail and whatever, it's pretty easy to switch between and your personal account. I'll probably just reply and ask you politely to send it from your Manitoba email address. Again, just to make sure that it's you that's actually trying to talk to me. That's a nice picture of me. These are professional headshots that were taken by the faculty, and I'm really proud of that, so I put it there for you all to see forever. This is a course that is an introduction to issues that are involved in real-world computing. And I'm going to tell you a little bit about what real-world computing means in a couple of minutes, but before you get to this course, you should have taken Comp 1020 or Comp 1021 if you're coming from St. Boniface. You should have taken or should be currently registered in Comp 2140, which is the data structures course. Some of the things that we're going to do in this course will rely on some of the things from Comp 2140, but like not the end of the course. I know that this term, Comp 2140 and 2160 are, one is like this and the other one is the whole summer. So we'll make sure that we're not relying too much on Comp 2140 stuff. The course material is all on Learn. So let's take a quick look at Learn. These are all the courses that I've taught over the years. Yours probably looks a little bit smaller than this, I'm assuming. These are all mine. This is our section for Comp 2160 this term. The parts that I want to bring to your attention are the course syllabus. So let's take a look at that first. The course syllabus is here. And the things that I want us to take a look at here are going to be the kind of the detailed prerequisites and what this course is about. So you've taken at least 2 programming courses. You've learned to program. Actually, have all of you done processing? Did you all do processing in 1010? Yes? Did any of you do Java? You did Java? Python. You did 1012. Yeah, okay. How many did Python in 1012? Okay. So you all know at least, I'm going to say at least 2 programming languages now. You all know at least processing, which is actually just Java, which you found out. You know Java, and maybe you know Python. A lot of the stuff that you do in Comp 1010 and Comp 1020, when you're writing code, it's really about just like getting the solution that works. I'm going to hack a bunch of Java. I'm going to hack a bunch of Python. I'm going to put something together. It gives me the correct output. End of job. I submit it and I get full points, and I'm very happy about that because I've gotten full points. In the real world, in your job, in your later courses, we're going to start to move away from getting the correct output is the best possible solution to a problem. There's more than just getting the correct output when you're writing software. There's also making sure that the software that you're writing is readable by other people. You're going to probably be working on a team when you are in industry. When you're in software engineering in 3rd year in Comp 3350, you'll definitely be on a team. We want to make sure that it's readable by yourself in the future. You're a slightly different person in the future, but I don't know about you, but I very frequently look back at old code I've written and wonder what the hell I was thinking. It's important to try and get that done. And it's important to try and make sure that the code that you're writing is, like, you can build upon it. When we're building code, ultimately, that's for a product, we're going to start with something small, and we're going to keep building on it over time. And making sure that our code is well designed and well organized is an important part of making sure that we can do that. That's what this course is about. We're going to use C, the programming language, and we're going to be using Linux, the operating system, but this course is not about C, and it is not about Linux or Unix. This course is all about writing software that is well organized and well designed so that you can use it going forward and other people can use it going forward. That's the main point of this course. The things that I want you to be able to do before you're coming into this course, the detailed prerequisites of this course, is that big enough for everyone in the back before I keep talking about this? Should I make it bigger? I can make it a little bit bigger. I know you're all giving me thumbs up, but I'm going to make it bigger anyway. The things that I want you to be able to do before you're coming here are things from Comp 1020. I want you to be able to write code that makes use of instantiation, objects in memory, and classes. So building up some small hierarchy of classes in Java. I want you to be able to know how to construct a new instance of a class. Use that new keyword to call the constructor of a class in Java. I want you to be able to write code that deals with large sets of data using files stored on disk. So this is writing that like kind of cumbersome try-catch block that uses maybe a buffered reader to get data from a file. I want you to at least minimally be able to implement recursive algorithms. You've seen this in possibly 1010, but probably not 1010 when you're thinking about binary search. This is more the searching and sorting algorithms that you saw closer to the end of Comp 1020. I want you to be able to implement those, and I want you to be able to design iterative solutions to problems. So you should be able to know how to like write a loop to be able to solve a problem that requires repetition of some block of code. I want you to be able to design and implement algorithms using arrays and basic linked lists. You started learning about linked lists in Comp 1020. And I hate to break it to you, but you're never going to stop seeing them in your undergraduate career. In Comp 3430 in operating systems, do you know what most of the data structures are? They're all linked lists. They're all linked lists. It's linked lists all the way down. I want you to be able to implement a linked list. I want you to have this idea of like a node that refers somehow to another node and then builds itself up that way. So being able to add things to a linked list and remove things from a linked list. I also want you to be able to implement simple searching and sorting algorithms. So I want you to be able to do things like linear search and binary search. I want you to be able to do things like selection sort and maybe quick sort. Those are the things that I'm looking for before you're coming into this class. By the end of this course, the things that I want us to be able to do is I want you to be able to write code using an unfamiliar programming language idiomatically. As you've made the transition from processing to Java or Python to Java, you've already seen this. You've already seen this idea of in processing or Python, there was a specific way to solve something. So I'm going to pick on Python here. In Python, there's a structure called a list comprehension. And a list comprehension basically lets you write a for loop on a single line inside square brackets, and you get a list out of it. You can't do that in Java. You can't do that in Java. It's not really possible or reasonable for you to write something like that in Java. In processing, there were certain functions that you defined. You're going to have to help me with this because I have never done processing. I have done processing, but it was a really long time ago. So there's set up, and then there's draw. Okay, what else? Key presses? Button down? Yeah, okay. So there's different functions that you implement that are kind of meaningless in Java. They don't really mean anything. They are Java, but they're meaningless in Java as a language. We're going to be learning C. That's not the point of this course. This is not a C course, but we're going to be learning C, and I want us to be able to learn how to write C idiomatically. Does everybody know what idiomatically means? Put your hand up if you don't know what it means. Everybody, just everyone put your hand up. Everyone put your hand up. Okay. So in English, idioms are like spoken language things or written language things. Phrases or concepts that exist in one spoken or written language that if you were to directly translate it into another language just don't make any sense. In English, when it's raining really hard outside, there's this phrase that is, it's raining cats and dogs outside. If you were to translate that to French or Tagalog or, I don't know, Spanish or Swahili or something, it would be more like you're literally saying there are cats and dogs falling from the sky, and that just doesn't make any sense. That doesn't make any sense. In French, I can't pronounce this correctly, so if you do speak French, forgive me, and if you don't speak French, just pretend that I have perfect French pronunciation. Il pleut des nails, because I can't think of the word that it is in English or in French. In French, you'd say something like, it's raining nails. But if you said that to a person whose main language was English, it's raining nails outside, what are you talking about? That doesn't make any sense. Those are idioms in a language. In Python, an idiom is list comprehensions. This is something that you normally do, that you'd normally see in a Python program. You cannot write that in other languages generally, so you don't see it in other languages. You can't express those things in other languages. We're going to be doing idioms in C, but the bigger goal here is to see how we take what we know from a programming language and think about the idioms in another programming language. That's the bigger takeaway here. We're going to be doing something called design by contract. And design by contract is a tool for developers, for us, writing code to be able to identify and fix problems easier than we would otherwise be able to do. Design by contract is a concept that spans across all languages that you might be using. So you can do design by contract in Java or Python or C in this case. We're going to be introducing you to testing. So taking code that you've written and verifying that it does what you think it does. We're going to be spending time doing design, so thinking about how to extract interfaces. You've maybe seen this a little bit in 1020 already, depending on when you went through, but we're going to keep talking about that. We're going to be talking about memory, and we're going to be talking about memory from a general perspective. And this is getting you toward Comp 3430 operating systems, but we're just taking little baby steps to start. We're going to be talking about performance. So how do we identify issues with code that's going too slow, and how do we fix those problems? How do we try to make it faster? And we're going to be spending lots of times looking at tools, so Unix and command line tools to build and run software. That's my information again. We're here right now. We're going to be here every day this week except Friday, and I'm looking forward to seeing you all tomorrow. And then below that, we've got a schedule. This schedule lists all of the things that we're going to be doing in the course. So I've organized it by week, and I've put the dates of when things are happening here. I've listed the learning outcomes that we're doing in the course this week. The learning outcomes here again are what you're going to be assessed on, and then approximately how you will be assessed. And then the deliverables, so the things that I'm expecting you to either turn in that week or things that we're going to be having like term tests. So the assignment due dates are all scheduled already. The first assignment is due next Friday. This is a compressed course. This is a 6-week course instead of a 12-week course. You kind of have to treat this course like you're taking 2 courses at the same time. We're doing 2 courses. We're doing 1 course. But you're coming to class like week 1 is today and tomorrow, and week 2 is Thursday and Friday. And then next week, we've got 4 more classes, and that's another 2 weeks of material in a normal term. When you're thinking about the time that you're committing to this course, you're obviously going to be in this classroom twice as much as you would be for other 12-week classes. But you also have to think about what you're doing outside of class. What you're doing outside of class, because this is effectively 2 courses at the same time, is going to be about twice as much as you would expect to do normally with a regular 12-week course that spans the term. So our first assignment is due next week, and that's in a regular term, like having about a month of time after the class has started for the first assignment to be due. Our term test is scheduled in the 3rd week. This is halfway through the term. This week 3 is kind of weird because Monday is a holiday, so that's the May long weekend. There's no class on Monday, so please don't come because I won't be here, and I think the door will probably be locked. So yeah, don't come to class that Monday. The class that's on Wednesday, the 22nd of May, is also going to be canceled. I'm very selfishly, I'm taking my daughter on a field trip that day, and I'll say this: I love her more than I love you. I'm sorry. I'm really sorry, but I'm going to go to a field trip with my daughter that day, so I can't be on campus. We will have our term test on Friday of that week, though. So if you look at Aurora, there's 1 extra class that's scheduled on Friday. That's the day we're going to have our term test for the term. The next assignment is due the week after that. On week 5, there's a little bit of a reprieve. There's nothing due. There's no tests. And then on week 6, we'll have our term test due on Thursday, June 13th. It's due on June 13th because that is the last day of classes, and I can't have things due after classes are over. But I'm usually pretty forgetful about that, and I'll remind you about how forgetful I am when it gets closer to assignment 3 time, and I usually make it actually due on Friday instead. But I'll remember to remind you how forgetful I am when we get closer to that time. Other than that, course materials and technology, the minimum technology requirements, you got to have a laptop. You have to have a machine that you can use to connect to other machines. I'm going to talk about the textbooks in just a second, so I'm going to skip over that. Some of the policies that I've got are related to sickness. If you are sick, please don't come to class. Please don't make other people sick in the class. This is a really compressed term. Missing time in this class can add up very quickly. So if you are feeling sick, please don't come to class. If you were here as I started the class today, you noticed that I'm streaming this on YouTube. I've put a link to this in our course notes section. I will stream every class that I am here. If you're sick, please stay home, watch the stream. Please don't come to class. If your illness is going to prevent you from showing up for the term test, or if it's going to prevent you from submitting an assignment on time, please use the self-declaration forms to notify me of that. I will accept one self-declaration form for the term. If there's something going on that's longer, talk to me, but a lot of times this turns into we'll have to go talk to someone else to get some help with that. Self-declaration forms are for 72 hours. They're short-term illnesses or reasons why you can't be participating in the class. If you miss the term test due to illness, give me that self-declaration form and the weight of the term test will be moved to your final exam. If you miss the term test, come and talk to me and I'll give you a copy of the term test at least so you're able to take a look at what kinds of questions you might expect to see on the final exam. If you're unable to submit an assignment on time due to illness, give me the self-declaration form and I'll give you an extension of 3 days to go on top of what the due date is right now. If I am sick, I'm not going to come to class. I don't want to make you sick. If I'm sick, I'm not going to come to class. I will first try to find somebody else to cover the class for me. There are lots of qualified people here that have taught this course before. Someone may come and stand in if I'm feeling sick. If I can't find someone to show up on time for the class, I will, if I'm feeling well enough, I'll send you all an email and say, please watch on YouTube, and I'll enable chat, and we'll just go back to COVID times and have remote class that day. And if I can't even do that, I will send you an email and just let you know that the class is canceled for the day. But I don't really want to be sick, so I'm gonna. Yeah, I can't promise that I'm not going to be sick, but I'll do my best to not. I don't know what I'm saying here. For class communication, like I said, please use your email address, your my Manitoba email address. If you have questions about assignments and course materials, the next place that we're going to be looking is the course discussion forums. If you have questions about course material or assignments, please ask them there. I have configured this so that you can post anonymously, so you don't have to feel like anyone's going to single you out because you're asking a question. Just ask the question. If you have a question, chances are pretty high that other people have the same question. I prefer this because I want to make sure that everyone in the course has access to the same information. If you send me an email and I answer your email, you're the only person that has that information. If you ask a question on the forum and I answer that question on the forum, everybody is able to see that same question and answer. If you send me an email that's a question about course material, I may politely just say, please post this question on the forum. That's a good question, but please post it on the forum so I can answer it for everyone. If you have questions about your assessments, so the grade or feedback that you've received for tests or for assignments, then yes, please email me and I will answer your question that way, because that is really just about you and it's not something that other people need to know about. I'm going to skip past this for now, but we will be doing an all against all scan of submitted assignments, so please make sure that you're doing your work by yourself in this course. I'm going to skip past this. I'm going to skip past this and this. The grade breakdown here, we're going to have 3 assignments this term, like you saw in the schedule already. Each one is going to be weighted the same. They're all worth 10%. We're going to have 1 term test. It is also worth 10%. And then we will have 1 final exam that's scheduled by the registrar's office in the last 2 weeks of June, and that will be worth 60% of your final grade. We do have this caveat that you must get a passing grade on the final exam to pass the course. So if you get something that's lower than 50%, then the outcome is that you would get an F in the course. The other policies and resources, you can take a look at the Schedule A link. This is also alongside this document, and it's a PDF, and you can find it on the course webpage. All right, does anyone have any questions before I keep trucking along here?
Suppose we can't get access to the teacher. How do we set the password without having to
Okay, that's a good question. I'm going to answer your question in just a couple of minutes, okay? So the question is about Aviary and connecting with SSH and changing passwords and stuff. And I'll talk about that in a couple minutes. We're okay otherwise? We're good? Okay, all right. So, what is real-world computing? The things that we're talking about in this course are issues that are frequently encountered when we're developing bigger software. In 1020, the assignments at the end were, they were getting pretty big. They were getting pretty big. Unfortunately for you, every course is going to feel like that after every time you finish it. And then you're going to look back at 1020 and think, what the hell? I could have done that in 2 minutes. Every course is going to feel that way. And then you'll get out into the real world and realize that software is very big, but there's also lots of people there helping you and working on it together. The kinds of things that we'll notice when we're building bigger software and when we're moving into industry is that we're going to be starting to use new environments and languages. This course, we're going to be looking at a new language, probably. We're going to be looking at a new environment, probably. It's likely that most of you haven't seen these environments before. When you get into industry and when you get a job, it will be a new language often and a new environment almost definitely. These are things that you're going to see as you keep going throughout your career. Software does not do very well when it just congeals. How many people have ever heard of this thing called Katamari Damacy before? 2 people? 3 people? Okay. This is a good one, I assume. Okay. I'm going to skip ahead just a little bit here. This is the premise.
Jack, we love Katamari's code into
you are this character right here.
Easy, right?
And you are rolling around a ball. And the ball just keeps getting bigger and bigger and bigger. And you can see here that it's measuring the size of the sphere as you push this thing around.
Character Valley.
In 1020, that's kind of how we built software. We started with the main methods, and then we just kept adding more and more and more. Our instructors tried to help us not do this by saying we need to have this method, and this method, and this method. And now we're going to start trying to think about how to figure out what those methods are for the course that we're going to do. Eventually this sphere will get big enough that it can start putting up buildings and stuff. Yeah. And then, this is absurd. He's connecting mountains now, okay? And,
oh yeah, we were 1 meter when we started this whole thing.
I forget the name of the main character, but it's like the king of the universe and all things that are evil. It's something. It's a really weird game.
This goes to show that with hard work and determination.
We're going to think a little bit about how to design software so that it doesn't look like that big Katamari. It's something that is intentionally designed, and it's intentionally designed in such a way that you can use it and other people are able to use it from the perspective of development, programmers, people who are writing code are going to be able to use your code. We're going to be spending time thinking about how to write code that does not crash, or at least if it does crash, at least it crashes gracefully. It explains why it has crashed so that the person that's looking at the software, the actual human that's sitting there, can try and possibly recover from the error that has that's happened. We're also going to spend time doing testing and debugging. We'll look a little bit more formally at debugging, and we'll start looking at testing for the first time, maybe. We'll also spend some time looking at performance issues. We're going to be using C and Unix to do all of that. These are the tools that we're going to be using to build all this stuff up. This is not a C course. This is not a Unix course. We are going to spend a lot of time looking at C. We are going to spend a lot of time looking at Linux and Unix, but this is not a C programming course. This is not a Unix course. We're also going to be spending some time looking at development tools. So we'll be looking at things like compilers. You've hit the run button in VS Code to start your Java. We're going to be spending time doing the same kinds of things on the command line to build C programs. We're also going to be taking a step back and looking at programs themselves that are designed to help build C programs, so compile them, and then lots of stuff on the command line. The textbooks that we're going to use, this is our first textbook. The Introduction to Programming Practices by David Skuse. This course textbook is on our course webpage. So I'm going to go to Content, and I'm going to go to Course Resources here, and I'm going to scroll down to Supplementary. The course textbook is here. This is a free PDF that you can download if you want to print it. Cool, you can print it. It's for your use in this course. Please don't distribute this textbook. This is something for you to use, but it's free and you could take a look at it. It's a little older, but it's still good. The main thing that I'm going to point out with this course textbook is that it starts discussing things relating to C in a little bit more of a linear fashion than we're going to be doing. So if I take a look at the basic C construct section here, it starts at page 1 and goes all the way to page 40 or so. There's stuff like enumerated types and unions. We will look at these, but not until like much later in the course. So if you're going to use this textbook, please do, but realize that we're not starting at the front and going to the end. We're going to be kind of jumping around a little bit throughout those things. The other textbooks that are attached to this course are, this book is called Programming Pearls. If you have taken this course before, you might have this book because this course used to have lab sections attached to it. I think that this is a good book. I do think that this is a good book. It's not a textbook, though, in my mind, in my opinion. This is not a very good textbook. This book consists of a bunch of things that were at one point columns in an ACM magazine. They've been taken and collected, and they are all really good little nuggets. Like, they're good ideas, they're good practices, but you probably won't see the value of this for 5 or 10 years. This is a good book. Don't get me wrong. This is a very good book, but as a second-year computer science student, it's maybe not the best book, and it's certainly not a textbook. I have this here if you want to come and take a look at it after class, just like skim it quickly. The bookstore has this book, I think. This is available on Amazon and stuff as well if you want to buy it. But you can come and take a look at it up after class if you want to try it before you buy it. The other textbook that's listed is the original C specification. That's this book right here, or this book right here. This is the first edition of the book, and this is the second edition of the book. Please don't buy these books. Please do not buy these books. You can buy these books, but only really used at this point. These are like the original reference manuals for the C programming language that was written in the 1970s and the 1990s. These are not good textbooks. These are not good textbooks. This first edition, if you do find it and you do want to buy it, please be aware that the syntax that's used for C programming has changed since this book was released. To give you a basic idea of what I mean by that, so we're all familiar with writing method signatures. We've got the return type, the name of the method, and then the arguments, and the arguments have types attached to them. In this version of the C programming language, you don't have to have a return type. You don't put the method arguments in the parenthesis. You put them on the next line before you start writing the function body. This is not a good textbook. Unless you want someone to look at your bookshelf and say, wow, that person's got a really nice book, please don't buy this textbook. I do have it here. Again, if you want to come and take a look at it, both of these editions, if you're going to buy any, buy the second one because this is closer to what we're actually using for C programming today. I'd still recommend that you don't buy this book, but you can come and take a look at them after class if you want to take a look at them. The other things that we've got up here that I'm going to point at, because I didn't have them in my slides, is in the supplementary section, we have this, I put a link to Modern C. This is a book that you can buy. This is a more reasonable C textbook if you want a C textbook. You can buy this book, or it is available for free as a PDF. It's a reasonably good book. I'm not going to follow it religiously, so if you are using this book, it's as an additional supplementary reference, but this isn't something I'm going to be using in class. This document, A Brief Introduction to Linux, VI, Vim, and Clang, we'll talk about each of these things, but this is a quick, short guide for you to use to get started. But I've also put a link to this, Introduction to Tools and Techniques in Computer Science. This book is referenced in this guide, but I thought it would be worthwhile putting this up here. This is the textbook for a course, the 2 lab courses that we're offering at the 1000 level, Comp 1002 and 1006. Can I get some thumbs up for 1002 and 1006? Everyone look back there. It's a good course. Oh, just those people, sorry. They've actually taken this course. That's why I'm pointing that at them and picking on them and making them feel super embarrassed, sorry. It's a good course. I like it. I made it, so I really like it. This is a course where we're taking the ideas of things where we're kind of like, you just got to figure this out on your own and trying to formalize those a little bit. So if you need some help with things like getting connected to Aviary, that initial thing that I put there, that brief introduction, does help you a little bit. But this is more like a lot more detailed about how you can get started with connecting to things like Aviary. So this is another resource that you can use. This is also freely available. You don't have to pay for this. You also don't have to take the course, but please take the course. It's a good course. You should take the course. Yeah. All right. So what I'd like to do now is to get a little bit of a sense of what kinds of experience you have with the environment that we're going to be looking at, with the programming language that we're going to be looking at, and some other stuff. So please take some time to answer this question. Okay, I'll leave this up for 10 more seconds. Okay, you can keep answering if you want. This is about what I expected. Lots of people having heard about it but never used it before. Some people never having heard about it before, and that's totally okay. If this is your spirit animal, this pug with the blanket, that's awesome. And it's totally okay that you've never heard of or used Linux before. If you have used Linux or Unix before, cool, great. I'm excited that that's true. If you are using Linux right now, I am using Linux right now. This is a distribution that's called Pop! OS. This is what I use on my laptop. I like it because it makes working with NVIDIA video cards a lot easier than with other versions of Linux. If you have used it before, cool, great. I'm really happy. Come and tell me what distro you're using. Maybe it isn't Ubuntu. A lot of people use Ubuntu. Maybe it's not. It's okay. I won't judge you if you are using something other than Ubuntu or Pop! OS. This friendly gentleman right here, I'm not sure what you see on your screens, but this is a man extending his middle digit at the camera. That's Linus Torvalds. He is the person that originally made Linux around like 1992. He was a student at the Helsinki University in Finland. And he was taking an operating systems course. He was an undergraduate student taking an operating systems course, and he decided, I don't like this operating system that we're using, so he just went out and made his own. This is him extending his middle digit at NVIDIA, because they are very bad at making stuff for Linux. Surprisingly, he has anger management issues. And he has thankfully taken a little bit of a step back from where he was at the time and is doing a better job of communicating with people in a more professional way than he used to. Let's say it that way. Okay. How much experience with C do you have? Oh, did you all just get to do them all at the same time? Okay, awesome, good. Okay, so how much experience with C do you have? This is what I expected to see. Lots of adorable little babies with no C experience. And that's totally okay. That is super okay. It's super, super okay that you're here coming in with no C experience. It's super, super okay if you've only done Hello World in C. It's super cool that you have done some stuff with C programs before. And it's really extraordinary if you read XKCD comics frequently. It doesn't really matter where you're at. This course is not about C. It's not about C. If you know C, good. If you don't know C, also good. We're going to learn C, but we're learning other stuff, and it's the other stuff that's more important in this course. Which operating system do you use right now? So lots of people are using Windows 10 or 11. I'm guessing most people using 11. Is anyone still using Windows 10? Some people? Okay. Nobody's using Windows 7 or 8 anymore. Lots of people are using Mac OS. Some people are using Linux. If you are using Mac OS, part of the reason that I'm asking this is I want to tell you a little bit about what you should do to your own system to get ready for this course. You're going to have to use these remote systems that I've referred to a couple times, Aviary, but most of the time you're probably going to work on your own laptop. If you are using Mac OS, you should install Xcode. Xcode has the C compiler that you need, and it has the build tools that we'll be using in this course. There's a command line only version of Xcode. If you do a search for Xcode command line tools, you'll find a command that you can run on the command line that will install just those command line tools, and it will not install all the building stuff for iOS and iOS, and it won't install the GUI for Xcode. Minimally do that, but you can install the entire Xcode if you want. If you're using Windows, quick show of hands, has anybody installed Windows Subsystem for Linux? A few of you, okay, good. The people who have a Windows machine in front of them that have not, it's very quick and easy to install. Search for Windows Subsystem for Linux, install. It's a single command that you have to run, and it will install effectively an entire Linux environment on your Windows system that you can just pop open with a terminal, and it's effectively the same as what's running on Aviary. It is effectively the same. I will not say it's identical, but it's effectively the same. This will be useful. This will be very useful for you to do. You don't have to do it right now, but do it at least as homework for tonight. Get your system set up to be able to compile C programs. Okay, great. That's it for that survey. Thank you all for doing that. I want to takes some time to do some general expectations. So in the classroom, I'm expecting you to participate. I have handed some of you these blue strips of paper. This is one way that I'm going to ask you to participate today. Don't write your name on it if you haven't already. Don't write your name on it. If you don't have a blue strip of paper, you can come and get one in a little bit. If you don't have a pen or a pencil, I've got lots of pens and pencils. You can come and get one of those in a little bit. I'm going to do coding examples in this class. Part of the reason I'm suggesting that you get your environment set up is so that you can code along with me. I'm going to do my very best to type slowly enough that you can kind of come along for the ride as I'm typing something in. Please take the time to participate when I'm doing stuff like that. You all participated by doing the survey. I'll have more surveys like this throughout the term as well. Please do your own work. I know that it's like we're all very friendly. This is an assessment of you as an individual to be able to accomplish some set of tasks. Making sure that you can accomplish some set of tasks is important, and that's the assessment that we're ultimately going to be doing for you, so please do your own work. You can, of course, talk to your peers. You can talk to people. Like, don't be afraid to talk to people, but it should be limited to things like high-level questions. It shouldn't be show me your code. Please don't ever send anyone your code by email. High-level questions and high-level discussions about course material is what we're looking for. The caveat to that is you can send me your code. If I ask you to send me your code, it's okay to send me your code. Please use Stack Overflow carefully. The last time I taught this course, one of the common questions that came up from students was this. How do I find the length of an array in C? And you do a Google search for how do I find the length of an array in C. Everybody's installing Windows Subsystem for Linux, and it's going real slow right now. The first thing that you find is the site that I'm sure you've all seen before, geeksforgeeks.org. Yes, the very reputable source of information. I'm going to skip past this because it has the same information that I'm going to show you on Stack Overflow. This is the top post on Stack Overflow for how do I determine the number of elements in an array in C. I guess necessary only. And no, I don't want to sign in for Stack Exchange. We're going to look at stuff like this, so don't panic if it's like, I don't know any C programming yet. We haven't looked at C programming, it's okay. This is the correct answer. This is the super correct answer. I'm going to straight up tell you that is wrong. It doesn't work in the general case. The very specific case where this works is when you declare an array, and kind of like in Java, you say how many elements there are in the array, so you know how many elements are in the array. But then you can ask this question, how big is it? And it will tell you there are 17 elements in that array. Cool, good, right? Yeah, excellent. I already know how long it is, but I can also ask the same question. In the general case, this is wrong. It doesn't work. In the general case, if you're doing things like passing an array to a function, this doesn't work. It doesn't work. It just doesn't work. And if you do kind of scroll past this and you keep going, and you see this comment that's upvoted very highly, don't stop reading here, read the next answer. The next answer is, it doesn't actually work. It doesn't actually work. And here's the right way to do it. It's okay to use Stack Overflow, but if you are going to use Stack Overflow, like, make a point of trying what they're doing in different contexts. Make a point of trying what they're doing in different contexts to see how long things are. If it's worth anything, and I'll tell you this again when we get to this point, but the correct answer here is if you're calling a function and passing an array, you also pass the size of the array as a separate argument in C. In Java, you just pass the array, and the array knows its length, but in C, it doesn't. We'll talk about that a lot more. The last time I taught this course was 5 years ago. And I don't know if you've heard, but in the last 5 years or so, there's this really cool thing that can like answer questions, kind of like an oracle. And so if I go to ChatGPT here, and again, very slowly, I ask it this question: how do I find the length of an array in C? ChatGPT will give me an answer. And I don't know if you noticed this, but it's giving me the same answer. ChatGPT was like helpfully trained on Stack Overflow. And so what Stack Overflow says, this is the correct answer, ChatGPT will confidently tell you, this is the correct answer. Yes. Fortunately, you can say things like, no, that doesn't work for functions. I cannot type. How do I do it in a function? And then it will tell me a little bit more. And then it will kind of tell me the correct answer here. One common approach is to pass the length of the array as a separate parameter to the function. The first answer that it gave me, very confident, yes, this is the correct answer. And that's because very confidently on Stack Overflow, yes, it was the correct answer. It's okay to use this to ask questions like this. Be wary of what it's telling you, because it's been trained on other people who sometimes say the incorrect things. If you are going to use this, try the code that it has there. Make sure that it actually does what you think it does before you get any further. You can expect me to stick around after class for a little while each day. I have office hours at 2 p.m., so on Tuesdays and Thursdays, I'm probably just going to go back to my office, and you can follow me if you have questions. But on Mondays and Wednesdays, I'll stick around for a little while, as long as there's not another class in here trying to set up shop. You can expect me to reply to emails that you send me within a reasonable amount of time. I try to respond to emails like within the same day that I get them, but if I don't respond to it within the same day, I do my best to respond to it by the next business days. Just to be clear, I don't check my email on the weekend, and I don't usually check my email after hours. I'm a person, and this is my job. It's my job, so I try to make sure that I have some kind of work-life balance, and the way that I do that is by not having email on my phone for work and not having email on my computer at home for work purposes. But I will try to answer your question by the next business day. I will also respect office hours, except for that day where I'm very selfishly going on a field trip to the zoo, to the farm with my daughter. I'm not going to have office hours that day either. Sorry. Okay, so that's been a lot out of me. What I would like you to do right now is take just about 30 seconds to think about this. What do you want to get out of this course? Don't write your name on this strip of paper. If you don't have a strip of paper, stick your hand up and I will come to you. If you don't have a pen or a pencil, also stick your hand up and I will try to come to you. You need both? You need both?
Yeah, it's a series of names.
You have a pen, good. Oh, okay, I'll get you another pen. Okay, I'm going to come back with 2 pens, okay? Oops. It's okay.
Thank you. I'm really using C++.
Just keep it. Just keep it. Yep.
So then,
Okay, it's been about 30 seconds. Just keep your papers right now. If you haven't finished writing down, just finish writing down before the end of class today. Just keep the paper for now. I will ask you to give it to me at the end of class. Like I said, don't write your name on it. If you have already, it's no problem. I'm not judging anyone for what they write, but this doesn't have to be something that you're writing your name on. Okay, so now that you've taken some time to think about what you want out of this course, let's talk about what this course isn't about. This is not a course about C. This isn't a course about C. This is really not a course about C. So many students, everybody, myself included, when I went through this program, said, oh, that's the C course, that's the C course. And now that I've taught this course a bunch of times, and unfortunately for you, it's taken me like teaching the course a bunch of times to realize this. You're all students taking this for the first or whatever time. This is not a C course. We're going to use C. We're going to learn a lot about C. C is a means to an end. We are learning C for a lot of different reasons. A lot of these reasons don't mean much right now, but they will mean more as we get through the course. The big things that I'm talking about in this course are things like how to design software. C is a language that is very simple. It's a straightforward language. This book, this is the C programming languages book. It is 270 pages long, and like this consists of a bunch of different appendices. So if I go back to like the beginning of where this stuff ends, we're talking about 170 pages of actual text. The C programming language is not a big language. If you printed out the Java programming language specification, it would be a massive binder. Java is a very complex language. If you printed out the C++ programming reference, which you're all gonna really love when you take Comp 2150, you're gonna wish that you could be writing C again. C++ is a language that, have you ever heard about this game called Katamari Damacy before? C++ is a lot like that. It's got features that have been bolted on and bolted on and bolted on. C++ is this language that's like, the C programming language is terrible, let's make something better. And never stop making a new language that's better. And it's just kept going over the years, and it just keeps getting worse and worse. This course is not about C. We're going to learn it, we're going to use it, but that's not the purpose of this course. This is not a course about Unix or Linux. In this idea of Unix, Unix is an operating system. How much time do I have? Not enough time to give you a history lesson right now. There's this idea of you've got a Unix beard, and the bigger your Unix beard is, like the better you are at using Unix. This course is not about Unix or Linux. You will be using these tools to accomplish a task, but that's not what this course is about. This is not a course about Unix or Linux. We will not be doing like mega Linux stuff in this course. You will not be a system administrator by the time this course is finished. You will be able to use the command line, but you're not going to be necessarily running your own Linux system. It would be super cool if you did, but that's not the point of this course. So with that, this is not a Unix course. Let's talk about Unix and Linux for a little bit. You are going to be using an environment in this course that consists of two parts. The first part is Unix/Linux. I am going to say Linux here instead of Unix. We used to use Mac OS for this, but we don't use Mac OS for this anymore. We're now using Linux to do it. This is just a better approach in my mind. The person that's running Linux on their laptop says Linux is better than Mac OS. Yeah, of course, Linux is better. Linux is definitively better than Mac OS. Fight me? I don't know where this is going. Linux is the environment that we're going to be using, and the other half of the environment that we're going to be looking at is text editors. Most of you are using VS Code, and I'm going to do my very best to convince you otherwise for the purposes of this course. Unix was developed in the 1970s by these two gentlemen right here. This is Ken Thompson and Dennis Ritchie. Ken Thompson and Dennis Ritchie, well, Dennis Ritchie is also one of the authors of this book, the C programming language. The C programming language was designed to build the Unix operating system. In the 70s, Dennis Ritchie and Ken Thompson were working at AT&T, which is a phone company in the United States, and they were tasked with building an operating system. And in the 1970s, it was kind of like you have to write an assembly language. And when you take Comp 2280, you're going to see assembly language for the first time. And you're going to think, wow, that's really painful. And that's how all stuff was done a long time ago. And the worst part about that was once you write a piece of software in assembly language, it works on a specific computer architecture. It will work on Intel processors and Intel processors only. And if you want to make it work on another architecture, you got to rewrite the whole thing. You just got to start from scratch and rewrite everything. The C programming language was invented so that we could basically write it once in a high-level language and then compile it down. This was not a new concept, but it was a concept that these two used to build up an environment that everything kind of worked together. Unix and Linux are typically used in a headless format. So what I mean by headless is, not literally headless, but like I've got it running on my laptop right now, yes, but most of the time we're running Linux and Unix on a server that doesn't have a display attached to it. There's no monitor that's attached to this thing. It's just going to be network cables plugged into it. And then a lot of people are going to use those systems at the same time. For us, we are going to be using a system called Aviary. This is an Ubuntu system. So these are all running Ubuntu. Aviary actually consists of about 25 computers, physically separate computers, that are all bird names. And Aviary is the name of a birdhouse. So we've got a bird cage, and then there's an aviary, and then all the computers in there are called bird names, like Wren and Robin and stuff. And it's a joke, and you're all supposed to super laugh hard at it, but nobody's even like smirking right now. Yeah, okay, one person's, yeah, okay. Linux is a Unix-like operating system. So Unix was built in the 70s, and then, Linus Torvalds with his middle digit extended decided, I don't want to use that operating system, I'm just gonna make my own. So he did make his own. Linux is a Unix-like operating system, and what that means is that stuff that builds and runs on a Unix system, like Mac OS, will probably build and run on a Linux system. So you don't necessarily take the program that compiles for your Mac OS and just stick it on a Linux machine and have it work, but you can take the source code that compiles on a Mac OS machine and compile it on a Linux system, and it will most of the time just work. This part of the environment has been selected for you. You don't have a choice. For your assignments in this course, they must work on Aviary. You must compile your code on there. You're going to hand in your code on there. Everything must work on Aviary. If it works on your computer, but it doesn't work on Aviary, it doesn't work. It must work on Aviary. I would suggest that you work on your own laptop, yes, but when you're working on assignments, test frequently on Aviary, or as I'm going to show you, just work directly on Aviary as opposed to doing it on your own machine. This part has been selected for you. We're going to start connecting to Linux machine right now. We're going to do it right now, all together. If you have a laptop in front of you, what I'd like you to do is open your terminal. You can find your terminal in a Windows machine by hitting the Start button, the Windows key, and start typing terminal. On Mac OS, the keyboard shortcut to start is like the Mac and spacebar, and then you can start typing. You can start typing terminal, and it will pop open a terminal window. And in a GNOME environment, you can start typing terminal, and it will pop open a terminal for you. I've already got a terminal open here. To connect to Aviary, you're going to connect by running the command SSH. This is secure shell. Your UMNet ID. So that would be, my UMNet ID is going to be super different from yours. My UMNet ID is UMBRIST1, but that's because I came here in the early 2000s, and I don't know why they put UM in front of everybody's name. It was a good idea at the time, and now I'm stuck with it forever. Your UMNet ID is probably like the first 4 or so letters of your last name and then your first initial. So whatever you use to log into your Outlook email address. I'm going to say fbristow. That's my CS Unix account name. Then you say @. This is the @ just like email addresses. And then you're going to say aviary.cs.umanitoba.ca. And then you're going to hit enter, and you're going to get a scary looking prompt like this one. If you have never connected to Aviary before, this is okay. This is effectively saying you've never connected to this machine before, or if you have connected to this machine, it looks like it's different than the last time you connected to it. If you can't connect, come and talk to me after class and we can try and work it out. At this prompt, you must type in yes. You can't type Y, you must type in YES, yes. It's going to ask you for a password. The password here, I'm going to open up just a new prompt here. The password that you're going to type in, if you have never connected to Aviary before, so you've never had a computer science account, the password that you type in is going to start with uppercase C, lowercase s, and then $. This is the same for everybody. And then your student number. I'm not typing in my student number, but your 7-digit student number. So if your student number is 1, 2, 3, 4, 5, 6, 7, the password by default is C, uppercase C, lowercase s, $, 1, 2, 3, 4, 5, 6, 7. What you're going to notice when you're at this password prompt is that if you start typing stuff in, so I'm hitting uppercase C, lowercase s, $, 1, 2, 3, 4, 5, 6, 7, it's not mirroring my output. It's not showing me that I've typed anything, but it is like accepting that input. Once you've entered your password, I'm going to hit enter and it's going to tell me that's a bad password. Once you hit enter, and assuming you can log in, it's going to ask you to change your password immediately. There's a password policy that's described immediately on the output. I've changed my password a long time ago and I can't make it happen again, sorry. But you'll see this password policy. You must match that password policy. So once you're connected, you'll see a prompt that looks like this one.
On the second password prompt, we have to write our own password, or
it should only prompt once. If it's prompted again, you may have misentered the password. Yeah. If you cannot get logged in, don't panic right now. You will be able to log in. Don't panic. I will put contact information for the people that you need to contact if you are unable to log in on the course webpage. So if you are having password problems, you'll be able to contact them. But the default is this structure of a password. So uppercase C, lowercase s, $, and then your student number is the default password. If you have had CS Linux accounts before, then it's the same password that you used the last time you connected. So you would have already changed your password, and you'd have to use that password again. Once you're connected, we're going to switch topics. So I wanted to show you a little bit about how to navigate around the file system. But instead, what I'm going to do is I'm going to switch to doing Hello World instead of navigating around the file system. That's where we're going to finish for today. So I'm going to close this pane. I'm connected to Aviary right now. I'm connected to Oriole. You might be connected to a different bird. There might be other bird names that you're connected to. If I type W here, there's at least one other person logged in here. I'm going to start by using a text editor on the command line that is called VI or Vim. And I'm going to use that to start editing a C program. So to edit a C program, I'm going to type vi and then the name of the program, the name of the file that I want to create. So in this case, I want to call it hello.c. And I'm going to hit enter. Once I hit enter, on the left side of my screen, you see these squiggles. And you've got the cursor blinking at the top, you've got the file name at the bottom, and you've got some other stuff that's showing up at the bottom of the screen. Vim is what's called a modal editor. So by default, we are in command mode. We can type stuff in, but what we're doing is giving commands to Vim to do things. With VI and Vim in your terminal, you cannot use your mouse. I am clicking on stuff right now here and nothing is happening. You cannot use your cursor. You cannot paste with your cursor. You can't right click and copy, because if you right click, it's just going to bring up like some other dialogue that has nothing to do with the Vim session that you're in. I can tell you a little bit more about Vim as we're going through the course, but to get started with Vim right now, we need to leave command mode and enter insert mode. The way that we enter insert mode is by pressing I on our keyboard. Once I pressed I on my keyboard, you can see at the bottom here now it says insert. And now I can start typing stuff. I'm going to start typing a C program. The first thing I need in my C program is $include stdio.h. So this is standard io.h. And these are angle brackets that are around stdio.h. This is the same as in Java, where we have at the very top of our program import statements that bring in a bunch of libraries. stdio.h is effectively a library that I can use for input and output. The next thing I'm going to do is I'm going to $include stdlib.h. This is the standard library. It has a bunch of stuff that's attached to it that we're going to use in this basic C program. Just like in Java, we need to have a main something. I'm going to call this a main function. I'm going to try to be very careful with the words that I'm using to describe these things. In Java, we have a main method. In C, we have a main function. Those are two different words that mean two different things. Methods are attached to classes. We do not have classes in C. We have functions. We need a return type. The main function in C has a return type of int. It's a number. It's called main in the same way that it is in Java. I'm going to, for now, write void here. As an argument, what this says is I do not want to accept any inputs to this function. You cannot call this function and pass anything to it. If I put nothing here, what this means is you can call this function and pass as much as you want to it, and it's fine. Void explicitly says you cannot call this with arguments. I don't want this to be called with arguments right now. In C, to print something to output, to make some output, we use a function that's called printf. Printf. It takes a string as input, kind of like system.out.print. But this is not println. It doesn't automatically put the new line symbol at the end of the line, so we explicitly have to type that in, hello world \n. Our main function must have a return type, so I'm going to say return exit success. I'm still in insert mode here. I want to be able to save this file. The way that I can save this file is on my keyboard, hit escape. And when I hit escape, you'll see that insert disappeared. And now I'm back in command mode. The commands that I want to enter here are write, W for write, and then I want to quit with Q. To enter a command, I have to press colon. So I have to hold shift and then press colon. And you can see that my cursor moved from the text at the top down to the bottom here. And I'm going to write W for write and Q for quit. Write is going to write out to hello.c what it says just above that, and quit is it's going to quit. It's going to exit Vim. So I'm going to hit WQ, and I'm going to type ls now. ls is list the contents of this directory, and now you can see that there's a file here called hello.c. I'm going to compile this, and I'm going to compile it in a way that I'm not expecting you to do right now. I'm going to show you another way to compile things, but just to get us started and finished quickly here, I'm going to say make hello. This runs a command, and what we have as output here is another file. It's called hello. And to run this program, I can say // is a period, and then a // and then hello. I'm going to do this again tomorrow. To make sure that we're all on the same page. But let me go back to my slides here very quickly. You should be able to find some course information on the course webpage. One thing I'd like to amend to this is that there are, like I said, course forums. There's also an honesty declaration. You need to sign the honesty declaration before you can see the course forums. Please sign the honesty declaration. You can now connect to a remote Unix server or Linux server. If you can't, you can come talk to me and we'll figure it out. You should be able to use a text editor on a remote system to be able to write a program or to create text files. You shouldn't be able to choose a text editor yet. We'll do this next time. Before you leave, I'd like you to quickly write down on the other side of that piece of paper, this is not a C course. Why would we choose C? Why do you think that we would choose C? Once you're done, bring your paper back up to me. Bring your pencil. If I gave you a pen or pencil, please bring it back up to me, and I will see you all tomorrow.